Here's the basic idea of net force. Consider a classic game of tug-of-war, where one side pulls with a force, say, of 1,000 newtons, and the other side pulls with an equal force of 1,000 newtons. The two teams will be pulling with equal forces, and a flag in the middle would not move. We would say in this case the net force on the center of the rope or the flag would equal 0. That's because 1,000 newtons pulling to the right added to 1,000 newtons to the left, which we would write with a negative sign indicating the opposite direction. And when we add those together, 1,000 newtons plus minus 1,000 equals 0. When forces on an object are balanced and the net force is 0, well, we call that balanced forces. Again, when forces sum up so that the net force is 0, this situation is referred to as balanced forces. Suppose the team on the left pulls now with less force than the team on the right. The net force in this situation on the middle of the rope will not be equal to 0. It will be different since the team on the right is pulling with 700 newtons more force, and it's to the right, which is the positive direction. The net force will be 700 newtons to the right. And we would write it this way. We would say 1,000 newtons to the right, which is positive. We're going to sum up with it at 300 newtons to the left, and when we write it down, we'll put the negative sign to indicate its direction. And when we summation here, it's like 1,000 minus 300, or the answer is 700 newtons. So in this case, the net force is equal to 700 newtons, a positive 700 newtons, which indicates motion, a force, a net force to the right. Here is another case where the team on the right is only pulling with 200 newtons, the team on the left with 800 newtons, and so when we sum these forces, plus 200 newtons to the right, combined with 800 newtons to the left, which is negative, the result here would be minus 600 newtons, so that's 600 newtons to the left, and that is the net force. So the net force is minus 600 newtons. Consider these four situations. The black dot is an object, and it shows two forces pulling in opposite directions. Calculate the net force. For this first one, the net force would be positive 4 newtons, that's 4 newtons to the right. For the second, it would be a minus 5 newtons to the left is the net force. The third one would have a greater force up, so it would be positive, and it is greater than the downward force by 6 newtons, so plus 6 newtons. Up is considered positive, down is negative. And for the last one, the downward force is greater, so it's negative, and it's greater by 4 newtons. So that's the net force in that case. To make it very clear, we could distinguish between the negative 4 newtons to the left and down by saying specifically that it's going down, or here in this case that it's going to the left. And for positive net forces, we could specify the direction as either being to the right or upwards. So what happens when there are both vertical and horizontal forces? Well, it's not too bad, but we have to keep them separate and to calculate the net force. We cannot add horizontal forces to vertical forces, just by summing them up. So in this case, you see 5 newtons up and 5 newtons down. Vertically, those cancel out. The vertical net force is 0. I like to mark them like that to show that they're equal. So they cancel out. So the net force on this object really just comes down to what's happening with the horizontal forces. In this case, it would be minus 4 newtons, or 4 newtons to the left. And on this one here, you can see that the horizontal forces cancel out. They're balanced horizontally. And vertically, 5 newtons up and 1 newton down would be positive 4 newtons in the upwards direction. And so there you go. That's how net force works. Net force is not a force itself. It is the sum of all the forces acting on an object.